Hi, in part 14 we will see about the assembly, how the components are assembled. We will see some introduction about that and we will create one assembly for practice. We will go to Creo, file, new. Here before that I will create two components, part A for better visibility we will create one color for the front surface. File, options, selection. I am disabling the okay. Now I am creating one more piece by doing save a copy. This is B. Okay, save this, file open. I am taking the component B. Here we have done B. Okay, now we have created two components A and B. I am going to assemble A and B in different ways. File, new. Here we have to select assembly, give the assembly name, remove the default template, give OK. Sorry, new ASSY, select the assembly name, move default, okay, select the unit, okay. Now we are getting three datum planes. This is the basic reference. In the model tree, if the datums are not visible, go to tree filters, pick the features, give OK. Now we can see these three datums. In space, if we want to place a component on space, we have to arrest all degrees of freedom. Each component having 6 degrees of freedom. We know already these things. X, Y, Z, all three axes translational movements, and with respect to X, Y, Z rotations. Totally 6 degrees of freedom. In Creo for assembly, we have to consider only the linear movements. No need to take rotations. So we will do one by one. First I am taking, see, we have to pick this tool, select the component. This is search window. Here we have to pick A part. Here in the placement, see, we have a lot of constraints to arrest the degrees of freedom. Here we have default. Default means, see, by picking default we are getting fully constrained. What default means? See, before that we will see this one. This is a separate window. If we want to see the component separately, we have to pick this one. See, now we are seeing here. In the assembly also we have the same component. If we don't want to see in assembly window, just off this window. Here we have three planes. These three planes, right, top, front. In the component, this is the component. See here the components model tree. Here we have three planes, right, top, front. Default means assembly right coincident with the component right. Similarly, top coincident with the component top. Assembly front coincident with the assembly front. Aligning. This is a default. We can give directly the default, or see, I am removed this. We can pick, see, right, pick the right, top, pick the top, front, pick the front. See, we get right, right coincident, top, top coincident, front, front coincident. Both are same. Default as well as aligning the data planes are same. Now we assembled a part. Now we have to assemble the another part, B. Pick this icon, search component name is B. We can, if we need the preview, we can see. If we don't want, we can off this preview. B part. I am going to place this B part over A part. So this surface must be coincident with the top surface of A. See, placement, go to coincident. This top surface coincident with the bottom of B surface. Okay, now we place it like this. Now we arrested one movement, vertical movement arrested. This surface coincident. In the assembly we can see it will be like this. See, these two surfaces are, if we flip, what we will check what happened. See, aligned. These two surfaces are, switch off the plane. These two surfaces now aligned, but we need mat, so flip. Okay, now the vertical movement arrested. I am going to arrest this horizontal movement. Next one, pick this one, coincident. This surface must coincident with this surface. So first one is component, second one is assembly. Sometimes if you pick the assembly, see, we have picked the assembly. If you select the component, it won't take. So if you want to select the component, it should be in component mode. Component, this surface, assembly, this surface, this and this coincident. Now we vertical movement arrested, horizontal movement arrested. Now front and back movement is there. We have to arrest. See, till that we will get partially constrained only. New constraint, coincident, this coincident with this. Okay, now fully constrained. Now instead of coincident, we can maintain some gap also. See, here if we pick the distance 10 mm above, see, we can keep like that. Here coincident. For example, if we want to be move backwards 10 mm means distance 15 mm, I am putting 15 mm backwards. It moved forward, so we have to give the negative value here. Okay, see, we placed one B. Similarly, if we want to place B in the side, see, I am taking one more component, taking B part. I am keeping side. Placement, coincident. Now this surface coincident with this surface. So horizontal movement arrested, then vertical movement, this surface and this surface has to be aligned. If we flip, it will go like this. But for we need like this, so we flip this one. New constraint. Now front and back movement is there. Coincident. This one coincident with this one. Sir, if you want to align with this surface, means remove this one. See, it will be like this. Okay. Now I am going to align one more B this side. Now instead of selecting the surface, now I am going to select the edges placement. See, this surface coincident with this surface. Instead of selecting this surface, I am only selecting this edge. This edge. Here it should be coincident. Okay. Then where is B? Here. New constraint. Coincident. This surface with this surface. Very first one we can B can assign different color. We don't know where is this. Oh, somewhere I think. Okay. Separate window we can keep. First one, this surface coincident with this edge, then this surface coincident with this surface, third one, this top one coincident with this top one. Okay, see, this coincident must be flipped. Earlier like this, if we flip like this. Okay, why I did these things means, instead of selecting the surface, we can select the edge also. Okay. Similarly, we can place a lot of components. Now we will see one real-time example for assembly. Okay, I am deleting these things. I have one image. This one. See, these are all the components we are going to assemble for learning. See, a lot of components. Where it is used means in the machine. Where is the machine image? This one. Here, the marked area. This is actuator end connector. Here on black color is there. A lot of end connectors are there. What we have seen is this portion. See this component. There is a bearing block and bearing with a shaft, one collar washer, and one more closing plate, universal joint, clevis, then pin with a circlip. We are going to assemble this component. We already have these Pro E models. We can assemble now. Okay, here we can assemble. Before that, I will bring the image inside. I am creating one datum plane to keep the image. I am inserting image. We have to select the datum plane. This image AB front. Okay, little visible is enough. Okay, now we are going to assemble this component. First one is the bearing block. Component assemble. This one, the first component we can assemble as a default. Okay, now we assembled this component. If we want to get the orientation similar to this, means we can edit definition, AB default orientation. See, it will be like this. Placement coincident, this plane coincident with bottom of this, new constraint coincident, this plane coincident with this one, coincident with, sorry, we already given this one in the assembly. We can flip, the orientation is like this. Okay, then we have to assemble the bearing. (30204) is the bearing. Okay, it should be inserted into the housing. So placement here coincident, this cylindrical surface coincident with this surface. Then now we arrested two horizontal movements, only the axial movement is there, we have to arrest that one also. Then coincident, this surface must coincident with the step. Okay, now fully constrained, give OK. Now we assembled the bearing. Then we have to insert the shaft, but in real first they will assemble shaft and bearing, then they will insert into the housing. For practice we are doing. Okay, stepped shaft should be inserted. See, this portion must be inserted into that. So coincident, this coincident with this one. Then there are two moments arrested with this. Then the axial movement coincident, this one with this one. See, we have arrested this. Then we have to closing plate. Now this one open, placement coincident, this cylinder, anyone, this cylindrical surface match with this cylindrical surface. Then for axial movement coincident, this top surface coincident with this top surface. See, in the assembly you can see, see, we have to flip this one. Okay, then the holes, any one holes must be match. So any one of hole match with the any one. Okay, see, then we have to connect the universal joint. This is a Misumi component, universal joint. Then coincident, this should be inserted into this. Then this is a pin, it should not be in this part. This is a bought out item, so the catalog it is available like this. So we have to coincident this surface with then we have to insert a pin, one pin with this and this one. Okay, then universal joint. Then we have to add the clevis, which is going to connected with the actuator end. Open. This must be inserted into this. Then we have only the axial movement. This is arrested with the aligning this hole with the cylindrical surface of this one. Okay, now we got the clevis. Then here we have to connect, see, this is the order we are following: bearing, shaft, closing plate, universal joint, clevis, then pin and circlip. Here we are inserting pin. It should be inserted here. In the slot we have to insert the circlip. So now we have only one movement along this axis. To arrest that, I am coinciding, see, this face with this step. We have to flip this, the second one we have to flip. Then here we have to insert the circlip. Both sides we have to insert the circlip. This one, and this face, but with this face. Okay. Similarly, opposite side. This is the way we have to assemble. Okay. As per the image, we are getting this one. In the next part, we will see how to create the exploded view like these things. Now, this is the way we have to assemble. Other things also you can do. For example, placement, new set. I am going. See, we have a lot is there. These things you can try yourself. Very easy only. So you can try yourself. Fix means, for example, if you want to fix a component here. See, if I want to delete this clevis, if I delete, it also delete the children of this pin. If you want to fix this one, see, we can delete all the constraint and fix. If we fix it like this, it won't move. Now if I delete this one or suppress, it won't affect this one. If you want to fix in a particular location, we can use that option. See, suppressed feature is not there, so tree filters, select the suppressed object, okay, then we can resume. Okay, that's all. Thank you.